Okay, ready?
Yep.
All right. So welcome to College Algebra. I'm going to do a video over your first section. In Chapter 1, you'll see Chapter 1 is labeled Equations and Inequalities. And here's how it's going to lay out. The first section, 1.1, is linear equations, which we'll talk about today's lesson. But just so you can see kind of how it fits in the sequence of what we're doing, this is kind of the foundation for algebra, the different types of equations we solve. And we've got the linear, and then we'll do some applications. So we'll have reading problems over those linear apps. Then we'll learn about complex numbers, which is the imaginary numbers will be included. So that will allow us to solve different types of quadratic equations. So we like to get that in there before we move to quadratics. So 1.4, we'll learn about quadratic equations, which means they're second degree equations. Then in 1.5, we'll talk about quadratic applications, so reading problems again. We'll have to do some reading problems in this chapter. Then 1.6, we have this odd little section we call other types of equations, and it hits some other odd situations that can come up. You know, these are the main two categories: the linear applications where x is to the first power. Then there's the quadratics, which x is to the second power. Those are the two most common types of algebraic equations that we solve. But there could be any other types. There could be to the third power, or what if you have a radical in it, or if it's a negative power, some other types of things that can come up but don't come up as often. So we'll hit some other types of equations in 1.6 to kind of wrap up different types of equation solving strategies. Then we'll talk about inequalities and absolute value. So that's the idea of chapter 1, to kind of see it as a whole. All right, so today's lesson, the first lesson in your material that you're responsible for, is over 1.1, the linear equations. So when you're solving a linear equation, you will have either one solution, you know, linear means to the first power, one solution, or sometimes there's just no solution, or you'll have infinite solutions. It's a special equation where everything works. These are the special cases. We'll see some of those as we go through our assignment, our lesson today, special cases. But typically, if it's a typical solvable equation, it will have just one solution. We call that a conditional equation. Whenever you get the solution, just the answer x equals. We like to see that when we're solving in algebra, that x equals something we can see and feel. So that's a conditional, when x equals a real answer. If there's no solution, we put this little symbol, that's the empty set symbol, and that means it was a contradiction. That's the type of equation. And then lastly, infinite solutions is where it was just an identity, where anything would have worked in the equation. It was kind of a special case where any solution works. All right, so let's jump into the examples. We'll start with example 1, kind of a traditional linear equation where we can get a solution to it, working through step by step. So the first thing you would do in this equation is you would notice that there's an understood -1 in front of this parenthesis that we can distribute. We can also distribute this 3, so let's do that. And get 6x and minus 12. Bring down your equal sign, and that is what makes this an equation. Anytime there's an equal sign in it, we've got a balance of the two, the left and the right side, and we're simplifying each side right now. Notice I cannot do this 7 minus 1. You might be tempted to do that, but what stops me is multiplication comes before subtraction. The order of operation would say you cannot subtract before you have worked out the multiplication. So 7 just brought down. The minus 1 then is distributed like so. Continue to simplify each side if possible. So on this right side, I have a positive 7 and a minus 5 that combines to be 2, and then the minus 1x. All right, so you should simplify the left and the right side as much as possible before you start moving terms around. So at most, you'll have 4 terms. You'll have a variable and a constant, variable and a constant on the other side. So at most 4 terms once you've done that. And then you'll want to consolidate your variables. Get your variables to one side. It really doesn't matter which side you choose. It works out the same either way. I'm going to take this minus 1x over to the left side. When a term moves sides, it changes its sign basically. And the reason is To get this term off of the right side, I do the opposite. I add 1x. So minus 1x and plus 1x canceled, right? But with an equation, whatever you do to one side, you have to do to the other side. So you have to also plus 1x to keep the balance there. Well, what it kind of looks like happens is you basically took this term, threw it across the line, and it became its opposite. So that's kind of a shortcut if you want to use it. But this is the reason why. Anyway, the minus 1x brought to the left side makes a plus 1x, giving me a total of 7x's. So I've got 7x minus 12 and a 2 left on the right side. So now I've got the x's consolidated. I'd like the constants to be consolidated. So I'm going to take the minus 12 to the right side. So bringing it across the line makes it a plus 12. So now simplifying, I've got just 7x on the left. 2 and 12 is 14. All right, so now we've simplified and got our variable to one side and our constants to the other side. And the last step in solving an equation will usually be if there's something in front of your variable, that means it's multiplied onto that variable. So times 7, the opposite operation would be divide. So 7 divided by 7 would then cancel the 7's out, but leave the x. It actually makes it a 1x. 7 divided by 7 is 1, but we don't always have to show that 1, but it leaves just the x. Do the same thing to this side, divide by 7, 14 divided by 7, and there's our x equals 2. That's an example of a conditional equation where you get an actual solution. Now, if this truly be the right answer, I should be able to take it back up into the original problem, plug it in for x. If x is 2, that condition is met. This is supposed to be a true statement. So I don't always do it. I'm kind of lazy about it, but it's a good idea to check your solution. So let's talk about how we check. If we believe x equals 2, in the original problem, I'm going to replace my x's with 2 and see if it works. So I've got 3, 2, replace that x with a 2. Oh, let's see if it'll fit on the board. Maybe, got it there. And then simplify. You can use your calculator, type it in each side, and see that the two sides truly are equivalent. But by hand, this would be 4 minus 4, which is 0. So that's 3 times 0, which is 0. That's 0 on the left. On this side, the parentheses first would be a 7. Then 7 minus 7 is 0. 0 equals 0 is a true statement. The two sides did come out to be equivalent, equal to each other. All right, well, let's look at example 2. Okay, so we're going to continue that idea, solving linear equations, and move it up a notch and add in the dreaded fractions.